And we are good to go. Today we're actually going to talk about functions. Like I said, I'm going to take this section, split it into 3 parts. Not only because of stuff that's going on, but also because there's a lot of material in this section. If you haven't already noticed, I try to start all the slideshows with a simple question of can you or are you able to? And so this will give you a brief rundown of all the things that we're going to talk about in this section. We're talking about function notation. We're going to talk about domain and range. Okay, domain is all the x values, range is all the y values. Sketch a graph. So we're going to talk about the mother functions, but then also talk about how to manipulate the mother functions to get the graphs of nastier functions, as I just mentioned. And what's a composite function? Cricket. Nobody knows? Well, then we'll find out. Some polynomial inequalities, some piecewise, remember those? Piecewise functions, those are fun. And I think we talked about step function already, but we'll review the step function, which will quickly become one of our new mother functions. You probably didn't have it last year as a mother function, but it will be for this year. Okay, so all of that in this section, we're not going to cover all of that today because it's a ton of stuff. We'll talk a little bit about it tomorrow. And along with eating some treats tomorrow, right? Who's up for Treat Tuesday? You guys got it all under control?
Yeah, sure.
If you bring something in that needs to be a refrigerator or something, come and find me in the math office in the morning and we don't want anybody getting food poisoning. Because I had food poisoning last weekend and it sucks. Anybody ever had food poisoning? It's a joy, isn't it? Yeah, that's fun. It's a great way to spend your weekend. Oh, so independent variable and dependent variable. I know you've heard these terms before. That's the biggest thing to get out of this slide. Independent variable, you choose it to be whatever you want. Okay, what's x? I'd like x to be negative 400. Great. Y is called a dependent value because y is dependent on what you choose for x. That's the basis of having a function there. You put something into the function machine, it does its thing, and spits out an answer. The thing it spits out is the dependent variable. The thing that you stick into the function machine is the independent variable. This is huge. You should have learned this last year. I'm not going to assume you did, and I'm going to go through this step by step. You have to be able to take a function. First of all, let's talk about the function notation. We're going to be doing more and more of f of x, g of x, h of x stuff instead of just y equals. Okay, so here's our function f of x. It's a simple parabola. What can you tell me about that parabola? Does it open up or down? Up, good. What's the 7 do to it? Moves it up 7. So the vertex is at 0, 7, and it opens upward. None of which is relevant to what we're doing. What we want to be able to do is come up with the expressions for what is f of 3a. So first of all, the question is, what does this mean in simplistic terms? Oliver.
You take 3a and plug it in for x.
You take what? I'm sorry.
3a and plug it in for x.
Correct. Real simple concept. Wherever you see x, put in 3a. Are you all with me? Okay, because for some reason we do this and then people start doing the actual work and everything goes to heck in a handbasket. Again, wherever you see an x, put in a 3a. Be careful with your parentheses. So f of 3a becomes what? 3a, fancy way to say that is quantity squared. Yeah? Plus 7. Easy peasy. And if you're feeling saucy, you could do this as 9a squared plus 7. Simplify that, but you don't necessarily have to early on. Any problems with that? Okay. Again, it doesn't matter what this thing is. It doesn't matter if it's 3a. It doesn't matter if it's b minus 1. It doesn't matter if it's smiley face. What is f of smiley face? Beautiful. Smiley face squared plus 7. Okay? Take whatever that thing is and stick it into the function for all the x's. If you have more than one x, it goes in for all the x's. When you're done, there should be no x's left. Okay, let's see. What is f of b minus 1? Go.
B minus 1 quantity squared plus 7.
Excellent. Let's take a little sidebar here and review squaring these. So you have to square this out, let's say. How do you do it? Do you write b minus 1 times b minus 1 and FOIL it? Or do you know the shortcut method? This is the audience participation part of the program. What do you do? Shortcut. Does everybody know the shortcut? Because you're going to do this a lot. You need to know the shortcut if you don't. Or shall I review it?
Let's review.
Square the first term. B squared is b squared. Multiply the two terms together. B times negative 1 is negative b. Double it. Negative b square. Negative b. Square the last term. Plus 1. Done. So our final answer would be b squared minus 2b, or not 2b. That is the question. We get that. So everybody's with me. You seem to have a firm grasp on it. And now the train's going to get derailed. Because everybody's going to freak out in the next step, but we're going to hold hands together and get through this. Here we go. What is f of x plus delta x minus f of x all over delta x? Okay, so let's take the first statement. F of x plus delta x. What is that? Go ahead.
Wait, is that the same as f of x plus h?
Yes, different version. Okay. So what's f of x plus delta x? We've heard enough out of you. Let's have somebody else participate. Or we just stare at each other for a little while. Okay.
X plus delta x squared plus 7.
X plus delta x, quantity squared, plus 7. Beautiful. Minus. Patrick, let's stay with you. What's f of x?
X squared plus 7.
Good. Now, most important of this whole mess, put in parentheses there. Whether you want to or not, put in parentheses. X squared plus 7. Otherwise, you will screw things up. Divided by delta x, and you're done. Okay, for some reason, that x plus delta x screws people up. They get all crazy about it. Then you can multiply that out. So what's x plus delta x quantity squared?
X squared
X squared.
plus 2x delta x.
Uh-huh.
X squared.
Plus 7 minus x squared plus 7. Well, that's, nope, minus 7. That goes away, that goes away, that goes away. Oh, I forgot the delta x on the bottom. Delta x. Okay, so that stuff all canceled, and we have 2x delta x plus delta x squared all over delta x. Factor out a delta x on the top. Notice I'm not canceling yet, I'm factoring out. That's kind of important. It will help you eliminate problems. Whoopsh, whoopsh. 2x plus delta x. And yes, you will have to simplify those bad boys. Well, that sure was fun. Wouldn't it? Any problems there? Beautiful. Plugging into a function. Unfortunately, in calculus, this thing will show up a lot. It is basically the foundation of what we're going to do for the first 2 months. I forgot to mention, in this class, we only cover 3 topics all year long. Limits, derivatives, and integrals. That thing plays an integral part, no pun intended, of the derivatives portion of the class. But we'll get to that later. Can I erase this? We're good? Okay. Domain and range. We talked about already, the domain is all the possible x values. The range is all the possible y values. What are the 2 things we're concerned about? What causes problems for us in the function world? Jimmy.
Negative square roots.
And?
0 denominator.
Okay. Anything else is fair game. If you run into one of those, then everything comes to a screeching halt. What values of x would bother me here? Do we have any square roots?
Yeah.
Hmm?
No.
No, so we don't have to worry about that. What about the zero denominator? 2 and -2. Beautiful. And as I mentioned earlier, everything is in interval notation. So you can't say x is not equal to 2 or -2. You have to do it in interval notation. And if you recall, it looks something like that. All of that gunk to just get rid of 2 and -2. Remember, infinity is always in parentheses, and then parentheses or bracket is depending on whether or not you're including the number. And since we're not including -2 and 2, they would be in parentheses. Okie doke. How about this guy? So, looking at this problem, I purposely included the graph because it's a little bit easier to do with the graph there. Because the graph automatically eliminates the domain for you. But you can see that there's no denominator, so we don't care about that. But we do care about the stuff underneath the square root. That cannot be less than 0. It can be equal to 0, it can't be less than 0. Hence the reason we're including 1 here. Okay, square root of 0 is fine, square root of 0 is 0. Done. As those functions get more complicated, the process is always the same. Take the radicand, the thing underneath the radical symbol, set it equal to 0, and solve. And we'll talk a little bit more about that when we get to, you'll recall in the beginning of the slideshow, we talked about doing polynomial inequalities. We'll be doing a bunch of that. Okay, so the domain here is all x's greater than or equal to 1. The range then becomes 0 up to infinity because this thing keeps going on forever and ever to the right and upwards. Nope. What does it mean when a function is 1 to 1? It means for every x value, there's 1 and only 1 y value. For every y value, there's 1 and only 1 x value. So a parabola would not be a 1-to-1 function.